Hi guys, welcome to Simple Programming. Today we're going to look at interface segregation principle. What does it mean? It states that the client should not be forced to depend upon interfaces that they don't use. Let's see it in action with an example. In our previous video, we looked at the dependency inversion principle. We looked at the example of employee profile. Let's take the same example. We had an interface called employee which had a method signature work. I'm going to introduce a new method signature called take break. Now let's take a look at our developer class and the architect class. I'm going to go to the developer class and you can see here the developer class has implemented the new method take break. The same goes for the architect class. So this is an ideal scenario. Now let me give you a scenario. What if the management plans to introduce a robot to do some work? The robot doesn't have to take a break. The robot doesn't have a lunch break or a tea break. Now, let's take a look at the robot class. The robot class has implemented the employee interface with the signatures work and take break. Take break is totally irrelevant for the robot. Now, do you understand the definition of interface segregation principle? The client should not be forced to depend upon interfaces that they don't use. Robot doesn't need to use the take break, but we have forced the robot to implement the take break method. This is what is meant by interface segregation principle. Let's try to fix this. I'm going to introduce a new interface called break interface, which is going to have a method signature take break. Apologies for the selection of the name, but let's go with this, okay, to make it as simple as possible, okay. And this break interface is going to have a method signature called take break, okay. Let's go to our employee interface and let's remove the take break from here, okay. It's going to throw errors in architect, okay, which because the employee interface doesn't have a take break. Now what I'm going to do is going to implement the break interface here. Now the architect implements both employee interface and the break interface. Let's go to the developer Java file. Let's do the same. The break interface. That's totally fine and it's good. The robot interface is now going to implement only the employee interface, and the employee interface doesn't have take break in it. So we can remove this. Now do you see how we have segregated the interfaces depending upon the needs of the client? Well, this is the importance of this principle. We also need one more interface which will put all these abstraction layers together and make it simple to use. So I'm going to name this interface as management interface that extends the break interface and the employee interface. Okay. Now let's go to the manager Java file. In the manager Java file, I'm going to uh, use the management interface which is going to have a setter in it, and then now you can see here, like when I do a management.work, it will get the work details of that particular object. When I do a management.takeBreak, it's going to give the take break information of that particular object. Now this particular manager class will work for both the architect, developer, and as well as for our robot. With this, we have covered all the solid principles that are very much important when it comes to designing an application. Thank you for taking time and looking at these videos. My next series would be Clean Code series. We are going to look at different code smells and design smells with respect to software development life cycle and how these code smells are affecting the developers in their day-to-day life and how to overcome those. Thank you.